Any questions over the homework before we get started? So what we did yesterday and the day before was multiplying and simplifying rational expressions. What we're going to be doing today is finding the quotient of rational expressions. Now, multiplication and division has one key difference between the two. And that's with division, when we're dividing two rational expressions, the first thing we do is we keep the first expression the same. So it's going to still stay 7x over 2x minus 10. Then we're going to change it from division to multiplication and flip the second. So dividing two rational expressions is the exact same as dividing two fractions. So we keep, change, flip. Questions on what we've done so far? No, it's the exact same as yesterday. Yeah, because now we just multiply the two together. Now before we multiply, we do need to factor. 7x. Stay the same. There's no way for us to factor or simplify 7x. Now the denominator, 2x minus 10, is there a greatest common factor between 2x and 10? 2. Because if we factor a 2 out of 2x, we're left with x, and 10 becomes 5. Any other expression that we have that has a greatest common factor? Yes, the x squared minus 6x has a greatest common factor of x. And if we factor an x out, we're left with x minus 6. Now our x squared minus 11x plus 30 has no greatest common factor between those three terms. But since the third term is positive, the signs are the same and match the sign of the middle term. So negative and negative. Factors of x squared would be x and x. Now factors of 30, yes. Since they're both negative, x minus 5, no matter which way we put them, we have the exact same thing. And if we do check and make sure, x times negative 6 is negative 6x. Negative 5 times x is negative 5x, giving us negative 11x. So those are indeed the correct factors. Now at this point here, we can multiply together. So on top, we'd still have the 7x times x minus 5 times x minus 6. Scroll down just a little bit. On bottom, now the 2 and x are going to come together because since they're outside the parentheses, we would multiply them together and we'll stick them up front. 2 times x is 2x times our x minus 5 times our x minus 6. So what simplifies? The x minus 5 and x minus 5, x minus 6, x minus 6. What else? The x's would simplify each other out, leaving us with what? It's not always going to be the case that all of our variable expressions cancel out, but it can work out that way. Yeah. Questions on this here? We ready for the next one? Find the quotient. And again, with dividing these rational expressions, we keep the first one the same. Change it from division to multiplication and flip. Keep, change, flip. Yeah. 11 is simplified, so it does stay. 3 goes into 3x and 9, so we can factor it out. Give us x minus 3. X is the greatest common factor of x squared minus 5x, reducing it to x minus 5. And the factors of x squared minus 8x plus 15, we would have x and x. Oh, minus, minus. Since the third term is positive, the signs are the same. Negative match the middle term, and yes, 3 and 5. Because it is helpful that the denominators do, for the most part, tell us what those factors are going to be. It gives us a hint, because if something's going to factor, we need those top two to be either x minus 3 and x minus 5. Now we multiply, we get 11x times x minus 3 times x minus 5. On bottom, we'd have x times x minus 3 times our x minus x minus 3, x minus 3, x minus 5, x and x, leaving us with, indeed, 11 over 3. That's it. Questions on this here? Let's see the next one. Keep, change, flip. So the 4x over 5x minus 20 stays the same. The second one, we're going to flip it. So we'll have x squared minus 6x plus 8 over x squared minus 2x. 4x is as simplified as it gets. 5 does go into 5x and 20, reducing it to 5 times x minus 4. X goes into our x squared and 2x. When we factor it out, we're left with x times x minus 2. So we have minus minus x and x, 4 and 2. And if we do check this here, we'd have negative 2x minus 4x, giving us the negative 6x that we wanted. On top, we'd have 4x times x minus 4 times x minus 2 over 5x times x minus 4 times x minus 2. And really everything, again, simplifies out, leaving us with 4/5. As hard as factoring can get. Because again, just like with multiplication, I think we're seeing that the key to doing this is less about the multiplication or division and more into, we get it set up, factor, simplify. Let's look at number 45. 4a squared minus 1 over a squared minus 4 is going to stay the same. We're going to change it from division to multiplication and flip the second. So now that our second rational expression is a minus 2 over 2a minus 1. Well, the a minus 2 and 2a minus 1 are as simplified as they get. A squared minus 4 will factor into almost. It is, I do agree with the A minus and A plus. It's going to be 2 and 2. Because A squared minus 4 is a difference of perfect squares. Because A squared, what times itself is A squared? A and A. A and A give us A squared, yes? What times itself is 4? 2 and 2. So we get A plus 2 times A minus 2. It's our difference of perfect squares. The numerator, 4A squared minus 1 is actually a difference of perfect squares too. Because what times itself is 1? Well, 1 and 1. What times itself is 4A squared? 2A and 2A. And we have our plus and minus. So again, it is a difference of perfect squares because 2A times 2A gives us our 4A squared. And then we can multiply them together. Well, at this point, we've just seen that they're just becoming one big rational expression. What's in common? A minus 2 and A minus 2. 2A minus 1 and 2A minus 1, leaving us with what? 2A plus 1 over A plus 2. So again, this is one of the first ones we've had that it didn't just end up being a number. It doesn't have to simplify down to a number. We can have these rational expressions on top and bottom. Questions on this here? Heat, change, flip. Heat, change, flip. Well, y squared is as simplified as it gets. Y plus 2 is as simplified as it gets. There's no greatest common factor there, and the degree is 1. Well, let's simplify the y to the 5th plus 3y to the 4th. There's a greatest common factor of what? Y to the 4th. And if we factor it out, we get y to the 4th times y plus 3. Y squared minus 9. How does that factor? Be y minus 3 and y plus 3. It's our difference of perfect squares. And again, we're multiplying them together. We're going to make this one big rational expression. Well, what's in common on top and bottom? And y plus 3. Anything else? No. So the numerator, when we multiply it fully together, we'd have y minus 3 times y plus 2. What do we have on bottom? We have y squared times y to the 4th, which would be y to the 6th, because when we multiply like bases, we add those exponents. Questions on this here? Questions on anything we've done so far? Are we ready for the next one? There it is. So we're going to keep the first one the same, a cubed plus 4a over our a squared minus 16. We change it from division to multiplication and flip the second expression. We keep it, change it from division to multiplication, and flip our second fraction. Now we can start some simplifying. A cubed plus 4a has the greatest common factor of what? A. So if we factor the a out of a cubed, we're left with a squared. Factor the a out of 4a, we're left with 4. So if we factor that a out, we're left with a times a squared plus 4. Yes, our a squared minus 16 is a plus 4 and a minus 4. The order in which we write those doesn't matter, because multiplying two things in any order is fine. Back to the top or the bottom? Bottom, a squared plus 8a plus 15. 8a plus and plus 15. 1 and 15, 3 and 5. 3 and 5. A times 5 is 5a. 3 times a is positive 3a, giving us the 8a that we wanted. On top, we do have a and a for a squared. Four and 5. Yes. Which one's going to be positive? Which one's going to be negative? 5 is going to be positive, 4 is negative, because if it is this way, we do have like factors. A times negative 4 is going to be negative 4a. 5 times a is going to be positive 5a, giving us the positive 1a that we wanted. And again, at this point, we can multiply these together. What's in common on top and bottom? Yeah. A minus 4, a minus 4. A plus 5, a plus 5. Anything else? No. It's very tempting to want to simplify out that a plus 4 on bottom with the 1 on top. It has to be the exact same. And since it's a squared plus 4, they don't simplify. Now the power with that a squared plus 4, the degree is 2. So there's a chance that it could factor. A squared is a perfect square, it's a and a. 4 is a perfect square, it's 2 and 2, yes? Is that a difference of perfect squares? No, it's a sum of perfect squares. We don't have a way to factor a sum of perfect squares, so that's as simplified as it gets. Questions on this here? We're good with this here. I think we feel comfortable with this here, yes? And I mean, even though that this is harder, it's just factoring our sum and differences of two cubes. We factor it and simplify. We're going to look at two more. This is going to be one of them, and I'll let you pick the last one. Now, just like yesterday, even though this second expression doesn't have a denominator written, it's understood to be 1, yes. So we would keep the first one the same, our 6x squared plus x minus 15 over 4x squared. We're going to change it from division to multiplication and flip. Keep, change, flip. So even though the denominator of the second expression is 1, we still keep it there. Yes, the 1, when we start factoring, is just going to be 1. The 4x squared is just going to be 4x squared. We can go there. I would look at the other one. 3x squared plus 5x. There's not 3 terms, so is there a greatest common factor? X. Because if I take the x out of 3x squared, we're left with 3x. Take the x out of 5, we have 5x. So that might be helpful. Now, our 6x squared plus x minus 15, no greatest common factor. Now, since the third term is negative, our signs are opposite. Factors of 6x squared, well, we know x squared is going to be x and x. So we have 1 and 6 or 2 and 3. Well, if we want something to match, the only thing that we can really match up with on bottom is what? 3x plus 5, yes? So if something's going to simplify on top, I need one of these to be what? 3x plus 5, yes? So if that's going to be 3x, the other has to be 2x. Now, hopefully the third term, 15, has a set of factors that contains 5. Well, 3 and 5, yes? Which means the 5 will go in with the 3x. 3 will go in the other spot. And let's just check and make sure. 3x times negative 3 is going to be negative 9x. 5 times 2x is plus 10x, giving us a positive 1x. Was that the middle term we wanted? Well, yeah. So, at this point, like we've been doing, we can kind of merge them together, multiply them. Now, the bottom we'll have to actually do some multiplying because we have those terms outside the parentheses. But for sure, the 3x plus 5 and 3x plus 5 will cancel. Now, all that's left on top is 2x minus 3 and what's 2x minus 3 times 1? On bottom, all we have left is 4x squared and x. 4x squared times x is 4x to the third. That's it. Questions on this here? Yeah. Questions on this here? Between the last two problems, which one do y'all want to do? I'll let y'all pick. Yeah, doesn't matter to me. Because with dividing rational expressions, again, we keep the first one the same. We're going to change it from division to multiplication and flip it. Even though it's not written, it's understood to be originally over 1. So when we flip it, the 1 goes to the top. Our other expression goes to the bottom. Five x squared is as simplified as it gets. 1 is the same. So we can do part of it so far because before we do our parentheses, is there a greatest common factor? It is 2. So let's factor it out. Because if we factor that 2 out, we're left with 3x squared plus 2x minus 1. On the other one, 2x squared plus 2x, 2x. And if we factor the 2x out of 2x squared and 2x, we're left with x plus 1. Now we can finish factoring the numerator. Since the third term is negative, our signs are opposite, plus and minus. Now we do normally start with the 3x squared factors. Then don't have to. What are the factors of 1, our third term? If I see that there's only one set of factors for the first or third term, I normally start there because that's a little bit nicer. Now we also know that the factors of 3x squared are going to be part of them.
Please come down to the front office.
It's going to be x and x. Now the factors of 3 are 1 and. If something's going to cancel, I need one of those to be what? X plus 1, then it'll match on top and bottom. So putting the 3 here, it will not work there, but it would also, if it did work, we wouldn't have anything in common. So we really want the 3 to be with the negative. If we check it, x times negative 1 would indeed be negative x. 1 times 3x is plus 3x, giving us a positive 2x, which is indeed the middle term we want. Now we can multiply these together like we've been doing. Connect that there. Now what's in common on top and bottom? X plus 1 and x plus 1. Anything else? 2. The 2 and 2. Because again, they're all being multiplied. So we can reduce that because of the multiplication. There's not addition or subtraction between our 5x squared and that 2x. So the 2 and 2 will cancel. 3x minus 1 is all that's left on top. And 5x cubed is left on bottom. Questions on this here? Questions on anything we've done so far? That's it.